Hello friends, welcome to another video of Zeta Axis, and today we will see how jet streams are formed. There are two forces which play a very important role in the formation of jet stream, that is the pressure gradient force and the Coriolis force. In this video we will see that how these two forces leads to formation of jet streams. Now pressure gradient is created due to two factors. The first is temperature difference in air masses. The air mass at the polar regions is cold while the air mass at the equator is hot. Therefore, there exists a very large temperature difference, and because of this we have a pressure gradient. We will see how this leads to jet stream in this video. And the wind circulation pattern also creates a pressure gradient because air is depleted from some places and air is collected at some places. Therefore, this creates a pressure difference. So let's see how pressure gradient is created due to temperature difference in air masses. Here we can see the temperature profile of our Earth. We can see that it is hotter near the equator while it is colder near the poles. Now let's consider an air column which is situated at the equator, and this is the air column. The red lines indicate the pressures at different heights. Now this air column which is situated at equator, when it moves towards the poles, we can see that the height of this air mass decreases because of the air cooling down, and when it cools down the density increases, and therefore the same amount of air mass which was here, it requires less volume to occupy, and therefore we can see that the height of this bar is smaller even though the amount of air in both of these columns is similar. We can see that these pressure bars which we have marked over here are also located at lesser heights. We can draw a line connecting them and we can see that there exists a pressure gradient. We can see that the pressure gradient is higher in higher atmosphere. At lower atmosphere, that is near the surface, we see that the pressure gradient is not that much effective. But in higher atmosphere, the pressure gradient is very high because the difference in pressure is very high in these two columns. And due to this higher pressure gradient, we see that the winds in the higher atmosphere move at a very high velocity, while the winds at the surface moves at relatively less velocity. Now in the higher latitudes, that is around 60 to 40 degree, we see that there exists a front. We see cold air mass over here and warm air mass over here, and here is a front. So at this front there is a drastic change in temperature, due to which a very large pressure gradient exists here in upper atmosphere, due to which the air moves at a very high velocity. Now remember, this high velocity is important because Coriolis force depends on velocity. Now let's see how wind circulation creates pressure gradient. We can see here headless cell, Ferrel cell and polar cell. Now over here in the headless cell, the air is rising up. Therefore there is accumulation of air over here. And this headless cell, when it comes over here, the air goes downwards, it descends. Therefore there is depletion of air from here. So we see that in a way there is a low pressure region in the upper atmosphere, and here there is a high pressure region, and due to which there is a pressure gradient. So this is how wind circulation also creates a pressure gradient in the atmosphere. Now let's discuss Coriolis force. We have already discussed Coriolis force in detail in another video, the link for which is available in the description. Coriolis force exerts a deflective force on any fluid. In the northern hemisphere, it applies a rightward movement on any fluid, and in the southern hemisphere, it will apply a leftward deflection to a moving fluid. Moreover, the Coriolis force is directly dependent on the velocity of the fluid. If any fluid which is moving fast, then it will experience more deflection, as you can see over here. This wind current is moving at 80 km per hour, while this was moving at 50 km per hour, because of which this air column got a large amount of deflection. Here we can see an air stream. This air stream is acted by a pressure gradient force. This pressure gradient force tries to move this air stream in the northern direction. Now right now there is no Coriolis force. But as this air stream starts to move northwards, a Coriolis force acts on this air stream. Over a time, the Coriolis force increases with the velocity of the air stream. And as this airstream continues to move northwards, its velocity increases, and there comes a time when the Coriolis force and the pressure gradient force are equal and in opposite directions facing each other. It is in the balance of these two forces we see that the airstream will move parallel to the latitude. It will not be able to go north of this, and both of these forces balance each other out, making this airstream to move in a parallel line. This kind of phenomena we can see for several airstreams. We can see that there are different airstreams and they all move in this direction. Therefore, the accumulation of these airstreams over here, it leads to formation of jet streams. These jet streams are situated 10 to 16 km higher in the atmosphere, and that is why they move with such greater velocity. These jet streams are around 200 to 300 km wide, and they are formed of different layers, and each layer has different velocity. We can see that the outermost layer is the slowest. It has a velocity of around 120 km per hour. The middle layer has velocity of around 150 km per hour, and the inner core has the highest velocity. It can reach up to 300 km per hour. These jet streams are also called geostrophic winds, because when the jet streams are in ideal conditions, they will move parallel to the latitudes. We can see that they are moving only under the influence of pressure gradient force and Coriolis force, and that is why they are called geostrophic winds. Any wind which flows under the balance of pressure gradient force and Coriolis force only, it is called a geostrophic wind. But these are ideal conditions. In normal conditions, you will see that there are meanders in the jet streams. They bend at certain location in the northward direction, while they bend in the southern direction at some locations. These bends are called Rossby waves. We can see here that there exists 4 jet streams, 2 in northern hemisphere and 2 in southern hemisphere. The one in northern hemisphere here is called polar jet stream, and the other is tropical jet stream, and similar is for southern hemisphere. And we can see that under normal conditions, all these jet streams, they show meanders, and these meanders, as we have seen, are called Rossby waves. I hope you liked our video on jet streams, and if you have liked, then please do subscribe our channel and share it with your friends. Please follow us on our Instagram and Twitter handles. Thank you.